Welcome to Data Encryption lesson. Oracle Cloud Infrastructure Block Volume Service provides persistent storage that can be attached to compute instances using iSCSI protocol or paravirtualized. The volumes are stored in a very high performance network storage and support automated backup and snapshot capabilities. Volumes and their backups are accessible only from within a customer's virtual cloud network and are encrypted at rest using unique keys. For additional security, iSCSI CHAP authentication can be required on a per volume basis. The object storage service in Oracle Cloud Infrastructure provides highly scalable, strongly consistent, and durable storage for objects. API calls over HTTPS provide high throughput access to all the data. All objects are encrypted at rest using unique keys. Objects are organized by buckets. And by default, access to these buckets and objects within them require authentication. Users can use IAM security policies to grant users and groups access privileges to the buckets. To allow bucket access by users who do not have IAM credentials, the bucket owner, usually it's a user that has all the privileges, can create a pre-authenticated request that allows authorized actions on buckets and objects for a specific duration. Alternatively, you can make a bucket public, which allows unauthenticated and anonymous access. Though given the security concerns, Oracle strongly recommends to carefully consider the use case or business case for making any bucket a public bucket. Object storage also enables you to verify that an object was not unintentionally corrupted by allowing an MD5 hash that is sent with the object. Or if you're using multi-part upload, then it is done for each part. This hash is returned upon successful upload and can be used to validate the integrity of that object. File storage service also provides encryption at rest and between backend, and backends are NFS servers and storage servers. In terms of backup, snapshots are available for file system storage service as well. In terms of data transfer services, Oracle uses standard Linux dencrypt and looks utilities to encrypt all the block devices. So as you can see, very strong encryption policies and utilities are provided for all different type of storage services that are available in Oracle Cloud Infrastructure. So here we basically have a pictorial representation of the data encryption at rest and transit. Here we can see that we have our compute and storage and data stored in multiple ADs in region 1 and then in multiple ADs in region 2. All data is encrypted at rest and also during transit. So the link between the regions is also secure and data is encrypted when it's transferred between these two regions if it is transferred. The keys that are used for encryption can be Oracle managed or customer managed. So what about database encryption? Database is also encrypted at rest and in transit. At rest, basically Oracle uses TDE encryption for backup at rest, or data is sitting at when the data is at rest. And then we use key store or wallet for managing the master key that is used to perform this encryption. For data in transit, you can use native Oracle Net services that provide encryption and integrity capabilities. All the Oracle Net services traffic is encrypted using very advanced encryption standards. So as you can see, you can also back up your database to object storage. Customers can choose to do their own backup, in which case they own the buckets. If they use Oracle provided automated backup, then the backup bucket is owned by Oracle. Now again, the whole point here is that there's encryption at multiple levels. There is no data that is not encrypted, whether it be database backup or data sitting in other type of storage such as object storage or block storage. Now, what about key management provided by Oracle? So Oracle key management uses HSMs that meet Federal Information Processing Standard or FIPS, and they meet Security Level 3 security certification. So what does it mean? This means that the HSM hardware is tamper evident. It has physical safeguards for tamper resistance. It also requires identity-based authentication, and it deletes the keys from the device whenever it detects any kind of tampering. So as part of this service, Oracle creates highly available key vaults that ensures that all your encryption keys are stored durably. You can create keys, you can quickly enable or disable the keys. Once you have disabled, you can quickly re-enable them as well. This is to ensure that these keys cannot be used by anyone else. Keys are rotated to ensure security governance and regulatory compliance needs are met. On top of this, you can write IAM policies that will ensure that only certain groups and users belonging to that group can manage keys and key vaults. And you can get even more granular in terms of IAM policies. So you can write IAM policies that allow only certain users and groups uh, to allow them to associate keys with other Oracle Cloud Infrastructure resources such as block volume, object storage buckets. You can use Oracle Audit Service to monitor the lifecycle of your keys and key vault. And finally, you can delete key vaults that you no longer are using. So now just to recap, as we saw that data encryption at multiple levels, all the data that is stored in OCI is encrypted, and then the keys that we use to encrypt them are very highly available, durable, and secure. Multiple levels of authentication is provided. You can tighten these controls even further using IAM policies. In the next lecture, we'll look at security control from authentication perspective.